In today's lesson, we're going to be looking at how to classify types of numbers. Numbers can be classified into two sections, either rational or irrational numbers. And we're going to look at a diagram today to very easily classify these types of numbers. So when we are dealing with numbers in math, we have what we call the real number system. Every number that you know of, that you've used, whether it be whole numbers, fractions, integers, decimals, these are all numbers that are in the real number system. Now, when you get into Algebra 2, you'll talk about a whole nother number system that is not a real number system. But the real number system is made up of these two types of numbers, rational and irrational. And today we're going to look at, okay, how can I classify in these two areas? So rational numbers are any number that can be written as a fraction, okay, a over b, or negative a over b. So that's what a rational number is. Now, let's go way back and talk about some other types of numbers that are rational. When you first started school and you started counting, way back probably in pre-K kindergarten, you were working with natural numbers. So natural numbers are all the numbers that we can count starting at 1. It's kind of like counting on our fingers. So natural numbers are 1, 2, 3, 4, 5, and then it just keeps going all the way to wherever, okay? So those natural numbers keep going as high as I can count. Those are natural numbers starting at number 1. After you worked a little bit with these natural numbers, you introduced another number, and that makes the classification of a whole number. So this classification of whole numbers, this circle, it includes natural numbers because they are inside of it, but also includes one more number, and that is the number 0. So it starts at 0, goes 1, 2, 3, 4, and it keeps going and includes all of the natural numbers. Okay, then we have our integers. Okay, that's our next circle. After you worked with these whole and natural numbers, adding them, subtracting them, multiplying them, dividing them, all that good stuff in school, in 7th grade, you introduce integers. An integer is a whole number that is both positive and negative. So if you want to make a note somewhere, an integer is a positive and negative whole number. Okay, so some examples could be like -3, -2, -1. 0 still fits as an integer, okay, because the whole number circle, okay, is inside of it, and the natural circle is inside of it. So, and then 1, 2, 3, and they just keep going all the way up. Then we have our rational numbers. So a rational number is anything that can be written as a fraction. If we look here at this circle, well, all these circles inside of it are also rational. An integer is rational. Can I take 3 and write it as a fraction? Yeah, 3 over 1. Okay, which is 3. So it is rational. Can I take a whole number and write it as a fraction? Yes, and a natural. So if it fits into any of those categories, it is also rational. But some other examples of rational numbers is anything that can be written as a fraction, like 1/2. 100 is rational. Okay, it can be written as a fraction. Decimals, some decimals are rational if they terminate or repeat, then they are rational. So if they terminate or repeat, and we know that terminate means they end, then they are rational. So anything like 2.5 because it ends, 1.333, and if that bar means it repeats, that is still rational because it is repeating. Now, irrational numbers are any number that does not fit into one of these 4 categories. So it's a number whose decimal form is non-terminating and non-repeating, which means it never ends and it never repeats, which means that this cannot be written as a fraction. The most famous irrational number is our number pi that we use mainly with circles. Anything that never ends, like 4.16753, and it keeps going, okay, that is irrational. Pi is irrational because it never ends, and nowhere in its sequence does it ever repeat. So the difference between rational and irrational with the decimals: rationals end or they repeat. Irrationals never end and they never repeat. So let's look at how can we classify. Let's look at some examples. First of all, what do we need to do to classify? First identify if the number can be written as a fraction. Okay, is it natural? If it's a natural whole or an integer, then it's automatically rational. Okay, or we need to look at the decimal. Does it repeat or terminate? If the number can be written as a fraction, then it's rational. If it cannot be written as a fraction, then it is irrational. So example 1. Which expression does not name an integer? Okay, remember, integers are positive and negative whole numbers. They don't contain decimals. So -15, that is an integer. 6/14, is that a whole number? No. Okay, so that's the one that is not an integer. 0 is an integer because 0 is a whole number and that circle was inside of the integer circle. Square root of 25, what times itself gives us 25? That's 5. 5 is an integer, so we're good. So how do we know that 6/14 is not an integer? An integer is a positive or negative whole number. It does not include fractions. Okay, which of the following is a true statement? -9 is a whole number. Well, if you go back and look at your screen, whole numbers only started at 0 and then increased or went up. So a negative number is not a whole number. So that is not a true statement. Square root of 36 is a rational number where the square root of 36 is a perfect square. What number times itself gives us 36? So the square root of 36 is actually equal to 6. 6, is it an irrational? No, it's whole. We're good there. It's rational. 0 is a natural number. Go back. Was 0 natural? Was that one of the first sets of numbers that you learned? Nope. 0 is actually whole. 2/3 is a rational number. That is true. Okay, and how do we know that 2/3 is a rational number? Because it's a fraction. Then it says rewrite all the false statements so they're true. So the first one should be -9 is an integer. Okay. And then B, let's see, that was A. B, square root of 36 is actually a whole number or a natural number. And then 0 is a whole number. We'll add that, or natural, up here. Okay, so your assignment for today, after you filled out your notes, you need to go through this daily practice. You need to print it out or something, fill it out. So number 1, you're just going to put an X in the box that it goes with. So I'll do the first one with you, 10. Okay, let's go way down. I like to start at this other side at the end and work my way up. 10, is it natural? Is it one of those first counting numbers that you started with? Yes. So I'm going to put an X in the box. Is it whole? Well, whole includes all naturals, so yes. Is 10 an integer? Is it a positive or a negative whole number? Yep, we're good there. Is it rational? Can I write it as a fraction? Yep, 10 over 1. So it is rational. If it's rational, it cannot be irrational. They have to be one or the other. And then all numbers right now that we are dealing with are real. So you need to go through and fill in the rest of this chart. And then number 2 and number 3 are pretty self-explanatory. Just answer them. They're like the ones that we just worked out on the practice. So you need to fill out this daily practice. You need to take a picture of it and send it in on Google Classroom for your assignment today. Also, there are 2 IXL assignments that are linked on your Google Classroom under this same assignment with the video and the notes that you need to finish. And those are due on Thursday, September 10th. So make sure you get those finished.